You can also apply the same process of simplifying radicals to expressions that involve x or y or variables as well, by kind of following the same idea and using the cancellation properties or fractions. So say for example I was asked to simplify the square root of 20x squared or these sorts of things. We could use the same technique. And what I would first suggest doing is splitting up the numerical component from the root component to begin with. Because the numerical component will simplify exactly as we were doing before, where, okay, 20 is 4 times 5, so I could break it down like that, and that would just be 2 root 5. And now as for the variable component, I could simplify those using the cancellation properties, where if I have the square root of x squared, they will cancel and leave me with just x. Or, I could rewrite it as a fraction. Remember, since this is index of 2 and this is x squared, this would be x to the 2 over 2 power, which would just leave me with x. But what's important to remember is that the square root of x squared does indeed cancel, but since it's an even index, it would leave me with the absolute value of x. And that's an important distinction for this expression. And a lot of times, the instructions of these sorts of problems in your homework might say, and notice how it says here, simplify the following assuming all variables are positive values only. And all that is saying is that technically the correct simplification of the absolute value of x, or of x, the square root of x squared, is the absolute value of x. But since it's positive, the absolute value is not necessary, and we can just rewrite this as 2 root 5 times x. And actually, just as another thing to mention, but in general you couldn't do this, but since we're assuming they're all positive, we can. And the last thing I wanted to mention here is that how a lot of times people will write this is they'll put the x before the root, just because it's a little bit, it can be like kind of hard to see, is the square root over the x or not? I mean, if you like, one way you can do it is if you actually close off your square root with another little tick mark at the end. That way we know for certain that the square root is only on the 5. And this is how I typically will write my answers, just because usually you put the number in front of the x, not after. So if we write it like this, to me it just looks a little strange, but a lot of people will write it this way just to sort of make sure that that root is not on the x, so you know for sure. So either form is fine. They're both the same thing, obviously, because multiplication is commutative. Heck, you could even write it as x root 5 times 2, but it just looks really weird. So anyways, not a big deal. And say for example we had a fraction such as this with the square root of this over this. We could apply the same sort of strategy. We could start by splitting the root on top and bottom. And then simplifying each one part by part. So again, I could then break it down as root 294 root y to the 7th over root 25 root x to the 4th. For some reason I wrote squared there, I don't know why. And then think about each component separately. Well, on the bottom, root 25 is just 5, and root x to the 4th is just x squared. And remember that what will happen here is how you can simplify these is by a fraction. This would be 4 over 2, 4 over 2 just makes 2. And again, technically it would be an absolute value, but we don't need to worry about that because the instructions say only dealing with positives. Now, for the other components, 7/2 is not easily simplifiable. Neither is 294 because that is not a perfect square. But again, I could apply the strategy we were talking about before, where I could think about, well, how does 294 simplify? So I could try factorizing 294. So 294 is definitely 2 times something. And if I'm not really sure what, I don't know off the top of my head what would be left over, we can always divide it out to see. That would leave me with 147. And then I could wonder, well, is 147 divisible by anything? I believe it's divisible by 3. That would leave me with 49. And 49, that is my perfect square. That's 7 times 7. So in 294, this is a little bit of a more challenging one to factor. It would be 49 times 6. And so that would be 7 root 6. And then in terms of y to the 7th, now it's kind of silly to actually simplify it this way, but I could always think about variables like to particular powers as, well, y to the 7th just means literally y times y times y. It means 7 y's. And so in the same sort of fashion, when I'm trying to simplify a square root, it's all about pairs. So it's kind of like, well, what's the smallest even number this goes into, which is 6. And basically I have 1, 2, 3, 4, 5, 6 pairs of y. This would leave one more y left over. So, basically with y to the 7th, I could write that as y to the 6th times y. Then I could split that apart like this, y to the 6th times square root of y. And then the square root of y to the 6th, since this is a perfect square, this fraction is 6/2, which would be y cubed. So essentially, when you're trying to simplify variables such as this, it's helpful to separate it, break it down, pull one of them out, and leave the rest even, because an even number will reduce by half. And since the square root means a 1/2 power, that would give us y cubed times root y. And anyways, that would be the final simplification of that one. Definitely a more challenging example. Sorry, there should be a square root on that y, as I said. But basically, you would keep the roots together. So I could reorganize this and rewrite that as, since 7 and y cubed were outside the radical, I'll put those in front, 7y cubed, and then within the radical usually comes second, which was the 6y. Everything else remaining. And again, that would be usually the more proper way of writing that answer.